All right, we're going to start chapter 10 with SOHCAHTOA with 30, 60, 90. And right now, chapter 10's little quiz. We're just going to start doing worksheets. So this will be the little quiz that we work on first. And this is 1 and 2 from that. The thing I want you to remember is SOHCAHTOA is written in a fraction. So the sine is opposite over hypotenuse. Okay? Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And so they're inverses. The inverse to sine is cosecant. So instead of an OH, it's an HO. The inverse to cosine is a secant. So instead of AH, it's an AHA. Okay? And the inverse to tangent is cotangent. So it's an AO instead of an OA. Alright? Things I like to keep in my memory is if it's a co, then there's a no co. So cosecant and sine. Cosine with secant. And tangent with cotangent. So every co goes with the no co. Okay? Co, no co. The other thing I like to keep in my head is secant be a ho. So it's a ha. Okay? If you can remember, just use your lettering as secant. Okay? So secant be a ho, so she's a ha. Okay? Okay, so it just gets that it might be a little funny and keep it in your memory. Okay? So to do these, right? Well, they're asking you, what is cosine? Right? Well, cosine of 27 degrees is adjacent, right, over hypotenuse, right? We don't have either of those, right? But what they're asking you is, well, what's the same thing? What's the same thing? And so we're thinking, okay, well, what is the same thing as adjacent over hypotenuse, right? Or this side over this side, right? And if we think about it, we could say this side, right, over this side, which would be the sine of 63 degrees, right? So what we're saying is, if we called this, instead of calling this adjacent, we just call it x. And if we call this y, correct? Then wouldn't this equal x over y? Is that correct? So then we're trying to see, okay, what else equals x over y? And x over y can also be written from the 60 degrees point of view. See how these are all 60 degrees? So 63 degree point of view is saying, hey, opposite, right, over hypotenuse is equal to sine. So therefore, we're looking for the sine. So the cosine of 27 degrees is equal to the sine of 63 degrees. And that's what they're trying to get you to see. Does that make sense? Okay? All right. Then the other thing they want you to see is, well, how do you put RS in there? And in the same aspect, we're going to hold this x here, okay? And we want to think about what they're giving us. They're taking it from the 27 degree point of view. So what we want to do is look at it from 27 degrees, right? And 27 degrees, right, is equal to RS. So what is that? So 27 degrees, think of that. Instead of saying x, we could just call it RS, right? Okay? So this is the same as x. Does that make sense? Okay? Then we got to think, okay, well, we could say the sine of 27 degrees, the cosine, cosecant, right? So the first thing we got to think about is when we're talking about 27 degrees and we're talking about 12, because obviously they want 12, right? So we're talking about 12. That's opposite, right? and we're talking about RS, which is adjacent, what deals with opposite and adjacent? Tangent and cotangent, right? Tangent and cotangent. So let's look at those two. So I don't even care about sine, cosine, cosecant, any of those. So we know it's not this, we know it's not this, it's one of these two. Okay? At this point you could guess 50-50 chance, flip a coin, right? First one, okay? Am I right or wrong? I don't know. Let's figure it out. So, RS, okay? If we talk about opposite, so tangent of 27 degrees is equal to the opposite, which is 12 over x, right? And the cotangent of 27 degrees would be the inverse of that, x over 12, right? And so if we multiply by 12, then 12 cotangent 27 is equal to x, which equals to RS, correct? So, A would have been right. Okay? And that's what they want you to do. They want you to use what you know, opposite over adjacent, adjacent over opposite, right? And then if you solved it, what would it be? 12 cotangent 27. Okay? Sorry I put that 27 like that. Okay? And that's 1 and 2.